3.4 polynomial functions, graphs, applications, and models. All right, so we are going to be looking at some functions. We're just going to graph them on our calculator. I'm not going to ask you to graph them by hand or anything. So we're just going to graph them on our calculator, and then we're going to determine where it is increasing or decreasing. And some will obviously do both. Some will just do one thing. So number 10, f of x equals 1/4 x to the 6th. So we're going to graph that function in our calculator. So y equals you have to clear whatever's there. So 1/4 x to the 6th. And then you'll have to hit zoom 6. So zoom standard. All right, so this graph starts out by going down, and then at some point it turns around and starts going up again. So I'm going to zoom in to see where that happens. So I'm going to zoom in to see where that happens. I'm going to hit zoom and box. So that's how we were zooming in yesterday. So I'm going to arrow down a little bit and over because I want to be able to see what's happening in here. Where it's turning around because I need to figure out what that number is. Hit enter and then arrow up a little ways and then arrow to the right, and you're going to create a box, something like that. Once you have that, hit enter. So I don't know if it's going. I'm gonna trace this function and see what's happening. All right, this one's a little harder to see it on just because of how it's working, but basically this one, as it gets to x is 0, that's essentially where we would say it's kind of starting like it's going down, and then it kind of curves itself back up and starts going up again. So hopefully the next one that we do will be easier to see what's happening so we can actually talk about it, because that one's just too tightly packed. So it is decreasing, I would say so decreasing is where the graph is going down, nothing crazy. So I would say from negative infinity to 0, so that we're looking at the x values. So negative infinity to 0. And then increasing from 0 to infinity. I'm going to type this next one. Well, all right, let's do 14. Let's see if that one's a little easier to see. F of x equals negative x to the 4th plus 2. So we're going to graph that. And notice the negative is just out front, so don't put parentheses around that or it'll give you a totally different graph. So negative x to the fourth plus 2. Everyone's okay with typing them in to graph them, right? Alright, so once you do that, zoom 6, because remember we had zoomed it in, so hopefully this one's a little easier to see, maybe not. Alright, so it goes up, 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 and then it turns around and comes back down. I want to make sure or see exactly where this is happening to ensure that I know where it's turning around. So I'm going to zoom box again. So zoom box, arrow to the left, down a little bit, hit enter, then arrow up and to the right. You want to get that entire part where it looks like it's turning around in your box. Hit enter. So what I was doing earlier, and it was just really hard to see on that particular graph, is if you hit the trace button, what this does is it allows you to follow your graph. So basically, as x is getting toward 0, I'm looking at it. So x is going that way. Y is getting closer and closer to 2. So at 0, so x equals 0, y is 2. Then as I go past that, notice that y is going back down. So that tells me that that is turning around at 0 also. So this one is increasing from negative infinity to 0 because the graph is going up. Oops. So increasing from negative infinity to 0, and then decreasing on the remainder of the graph, so from 0 to infinity. So that's where it would be going down. So this is literally just like look at the graph and then write where it's going up or down, essentially. Let's see. Let's do one more like this one. 16, because I know you'll be able to see what's going on in this one. F of x equals x plus 2 cubed minus 1. So we'll type that one in. So we're in parentheses, x plus 2, cube it, and then subtract 1. And then zoom 6, because remember I had it all zoomed in from before. So cubic functions are interesting. They look something like that, where they typically are constantly going up unless it's been reflected. So on this graph, I'm not actually going to zoom it in, but the only area that looks like it could be turning around and possibly have something where it's not just increasing potentially is right here in this middle area. So I'm going to hit the trace button, and notice it put, well, for me it put it up here on the graph. So I'm going to follow it down. So as my x is getting more negative, y is going down, and y is constantly getting smaller. So that tells me that this is one like continuous thing. It's not turning around and changing. So this graph is increasing on the entire thing. There's nowhere that this graph is decreasing. The only spot it looked like it could be was here, and by tracing the graph, I can see that it is not. So this graph is increasing only, and I would say that that's happening from negative infinity to positive infinity. Because if I extended this graph and looked, it's going to just keep going on forever. Any questions about this? Kind of makes sense. The hardest one is probably the one that was the x to the 6th. I'm not inclined to give you like an x to the 6th unless it's like very obvious what's happening, just because of how they work and stuff like that. I'm more inclined to give you one like 14 or 16. let's see. Let's focus back in now. The next thing says to use an end behavior diagram to describe the end behavior of the polynomial function. Okay, so what that means is for 21 through 28, they want you to show that the graph is doing something like this, like this, like this, or like that, okay? So they want you to essentially just show where the graph is going, okay, each piece of the graph. So to do that, the easiest thing to do is using limits, and we only need to look at the highest powered term. Nothing else is going to make a difference, okay? So odd functions, so x cubed, x to the fifth, any of those kind of things, they're going to be going opposite directions, okay? One's going to be going to positive infinity, the other's going to negative infinity. If it's an even function like x squared, x to the fourth, x to the sixth, it's going to be pointed in the same direction because no matter what number you plug in there, it's going to end up being positive, or if the whole value is negative, then negative. So it's going to be going the same direction. Whereas odd, if I plug in a positive value, it's going positive, but if it's a negative value, the answer is going to be negative. So that's why they're going opposite. Okay, so 22, I've got f of x equals negative x cubed minus 4x squared plus 2x minus 1. So I'm going to look at the limit as x approaches negative infinity of f of x and the limit as x approaches positive infinity of f of x. Have we done limits in here? All my classes are running together, so I don't know. Okay, so limits, this is something that a lot of college professors will tell you they didn't understand until they had taught it for a couple years to really understand what a limit is, okay? You don't really have to understand what it is, but basically the way I think about limits is what happens as x gets really, really big or really, really small, okay? So as it goes to negative infinity, x is getting really, really small. As it's going to positive infinity, it's getting really, really big, okay? So I typically, when I'm doing limits, and this will come into play more later in the year as we do other stuff, but I will typically choose a number like 500. For the sake of this problem, I don't even have to choose a number that big. I can choose like 5 or 10, and it's going to still help me to see what I need to see, okay? So if I plugged in, let's say negative 10 for x, all I care about in these problems is the highest powered term and the sign in front of it, okay? This is a cubic function, means it's odd, so I know that my answers have to be opposite. So if one of them is infinity, the other one's negative infinity, okay? So whatever the highest powered term is, if it's odd, your answers have to be opposite. If they're even, they have to be the same, okay? It's kind of like your hint, I don't know. So if I plug in, let's just even say 5, okay, or negative 5, because we're going to do the negative one first. What is negative 5 cubed? And I don't even really care what the number is. Is it positive or negative? Negative, because the negative cubed is going to stay negative. But it's also getting multiplied by a negative. So what is that going to mean? Positive. So this one is going to positive infinity. Okay? Now, if I plugged in positive 5, 5 cubed is, I don't care what the number is, just positive or negative. Positive times a negative, negative. So this one's negative infinity. So notice, odd function, opposite answers. So odd opposite, if that helps. Let's see. (26) f of x equals 10x to the 6th minus x to the 5th plus 2x minus 2. Okay, so same thing. I'm looking at the limit as x goes to negative infinity and the limit as x goes to positive infinity. All right, so is this an even or an odd highest power? Even. So what does that mean about my limits? They're going to be facing the same way. So if I plug in, we can even just say like -2 raised to the 6th power, what's that going to be? Just the sign. Positive times 10, which is positive, so positive infinity. If I plug in 2 here, what would my sign of this thing that's circled be? Just 2 or whatever. Yes, a positive. So this one's also positive infinity. So it's an even power. They have the same sign. I'm good to go. And in case you're wondering, like, why are we only looking at the highest powered term? That's because the farther out toward infinity you go, the less the other things are going to matter. Because if I raise 500 to the 6th power, I don't even know what that number is going to be, but it's going to be excessive, okay? So 500 to the 6th power times 10, that's a really big number. Subtracting off 500 to the 5th power, not going to do a whole lot. Like, it's still going to end up being a really, really big number, like regardless of what number gets plugged in there. So that's why we only care about the highest power term when it comes to that. So one more. F of x equals 7 plus 2x minus 5x squared minus 10x to the 4th. So what's different about this one compared to the previous two? They're not in the proper order, which, not the end of the world. Okay, it doesn't say I have to write it in standard form, but what does that mean when I go to find the limits? Which term am I looking at? Yep, so the negative 10x to the 4th. So I just have to pay attention to that one instead now. So the limit as x approaches negative infinity of f of x and the limit as x approaches infinity of f of x. So if I plug in a negative number and raise it to an even power, what happens?
If you take a what?
A negative number and raise it to an even power.
It's positive.
It's positive. And then multiply it by a negative, I get. So this one's going to negative infinity. If I take a positive number like 2 and I raise it to the 4th power, obviously stays positive. Multiply it by negative 10, becomes negative, so negative infinity. So even power, same signs down here. Any questions on those ones? All right. So this section has some other graphing in it. I don't normally have y'all like graph them. One, because graphing them on your own is a pain, and I feel like if you were to ever see one like that on an SAT or something like that, you can plug it in the calculator and it'll graph it for you. I also don't think you would see something like that on the SAT because I just don't think that's what they put on there. Anyways, if there's just a graphing question that says graph the equation, you would just graph it on your calculator. and then just copy it exactly as it looks on your calculator. So we're skipping that stuff because I trust that you can plug numbers in your calculator. So have to do it earlier in this section anyways. We did it in the last section to find zeros, so not too crazy. So the next stuff in here says to use the intermediate value theorem to show that each polynomial function has a real zero between the numbers given. Okay, so using the intermediate value theorem, IVT, so number 48, f of x equals 3x squared minus x minus 4, and the numbers are 1 and 2. All right, so intermediate value theorem, let me find the official wording I have here, says if f of x is a polynomial function with only real coefficients, and if for real numbers a and b, the values f of a and f of b are opposite in sign, then there exists at least one real zero between a and b. Okay, so what that means is if I test both of these numbers as synthetic division, one answer should come out positive and one answer should come out negative, and if that's the case, then there is a real zero somewhere between 1 and 2. So I just use those numbers exactly in synthetic division. So 1, then I do the same thing like I would have been doing in the last, 2 sections that we've done. Copy down the numbers exactly. If there's a missing term, still have to put the 0 in there. I don't have any missing. So 3, negative 1, negative 4. Bring down the 3. Times 1 is 3, minus 1 is 2, times 1 is 2, minus 4 is negative 2. So the way we would write this is f of 1 is negative. All right, so if I evaluate it at 1, that one's going to end up being negative. Use 2 and do the same thing, but I have to use the original numbers when I do this, not the factored numbers. I can't really use this because I had a remainder anyways, but just so you know, use the original numbers. So 3, negative 1, negative 4. Bring down the 3, times 2 is 6, minus 1 is 5, times 2 is 10, minus 4 is 6. So notice this one is positive, that one was negative, so f of 2 is positive. So by the intermediate value theorem, so I would just say by IVT, there is a real zero between 1 and 2. So nothing too crazy. It's just two synthetics, and just say that, one has to be positive, one has to be negative. If for some reason, I haven't come across one in the book like this because they're wanting us to show that it has a real zero. But if for some reason they were both negative or both positive, there would not be a real zero between that. Okay? Like I said, I haven't come across one that has been that way, but I just want you to be aware that that could happen if you were ever just checking it and that wasn't necessarily what you were looking for. One more of these ones. 50, f of x equals 2x cubed minus 9x squared plus x plus 20, and the numbers are 2 and 2.5. So I have a decimal one this time, which isn't necessarily fun, but that's okay. So 2 first, and then no missing terms. So I've got 2, negative 9, 1, and 20. Bring down the 2. Times 2 is 4. Minus 9 is negative 5. Times 2 is negative 10. Plus 1 is negative 9. Times 2 is negative 18. Plus 20 is 2. So this one is positive, so I would say f of 2. If you even want to just do symbols like that and show that it's positive that way without writing out the word, totally fine. Now 2.5, this one potentially could be a little bit more fun, we'll see. Same number, so 2, negative 9, 1, and 20. Bring down the 2. 2 times 2.5 is 5. Okay, maybe it won't be that bad. Minus 9 is negative 4. Times 2.5, that would be negative 10. Plus 1 is negative 9. Times 2.5 would be, oh goodness, 22.5, I think. Oh, but it's negative because this was negative. So then I get a negative 2.5, right? Yeah. Yes. So f of 2.5 is negative. So then I would say by the intermediate value theorem, there is a real zero between 2 and 2.5. So on the quiz, you would need to have this to explain what you have shown, by the fact that one is positive and one is negative. Okay, so you need this concluding statement with these problems. Any questions about that? All right, the last thing in this section, still pretty easy, says to show that the real zeros of the polynomial function satisfy the given condition. So basically, it's that there's no real zero greater than a number or no real zero less than a number. The way that we determine that is with the boundedness theorem. That was at the very end of your notes. So if C is greater than 0, so that means the number that is getting plugged in, and all numbers in the bottom row of the synthetic division are non-negative, so either 0 or positive, then f of x has no 0 greater than C. If C is less than 0, and these will be the numbers that we're plugging in, that's what C is, and the numbers in the bottom row of the synthetic division are alternating in sign, so it'll be like positive, positive, or whatever. A lot of times, I think in the pre-cal book, we'll say non-positive, non-negative, non-positive, non-negative, because 0 can fit either of those requirements. Okay, it's not super often that we end up with a 0 in the bottom line, but sometimes that does happen, so just be aware of that. So 58, I've got f of x equals 2x to the 5th minus x to the 4th plus 2x cubed minus 2x squared plus 4x minus 4, and it says no real zero greater than 1. So whatever number they tell us here, that's what's getting plugged in for synthetic. So 1 goes in here. Still, if there's any missing terms, we would need to have that, but there's more than enough terms here. So 2, negative 1, 2, negative 2, 4, negative 4. And so no real zero greater than 1. We are looking for all the numbers at the bottom to be non-negative, so either positive or 0. Okay, so we bring down the 2, times 1 is 2, minus 1 is 1, times 1 is 1, plus 2 is 3, times 1 is 3, minus 2 is 1, times 1 is 1, plus 4 is 5, times 1 is 5, minus 4 is 1. So the way that this would conclude, 1 is greater than 0, okay, because that's the C is greater than 0 part, and all numbers in the last row, so that just means this bottom row here, are non-negative. So no real zero greater than 1. Does that make sense? Let's see. So that's greater than 1, or like greater than. Everything is non-negative. Now, 60, f of x equals x to the 5th plus 2x cubed minus 2x squared plus 5x plus 5. And it says no real zero less than negative 1. So, negative 1 is what goes in synthetic. Now, notice x to the 4th is missing, so I'm going to be putting in a 0 there. So I've got 1, 0, 2, negative 2, 5, 5. So for no real zero less than 1, I'm looking for alternating non-positive, non-negative. It does not matter which the first number is. I mean, obviously in this case, it's going to be non-negative because it's going to be a positive number. But it does not matter which thing starts as long as they are alternating all the way through. So 1 times negative 1 is negative 1, plus 0 is negative 1, times negative 1 is positive 1, plus 2 is 3, times negative 1 would be negative 3, minus 2 is negative 5, times negative 1 is positive 5, plus 5 is 10, times negative 1 is negative 10, plus 5 is negative 5. So down here, I've non-negative, non-positive, non-negative, non-positive, non-negative, non-positive. And again, I'm saying that because 0 can fit either of those requirements. So, concluding, negative 1 is less than 0, and the numbers in the last row are alternating. I'm just going to say alternating sign. So, f of x has no real zero less than negative 1. Any questions about that?
I have a question, but it's unrelated.
That's fine.
How many weeks are left in this quarter?
So next week's only a partial week. It's only 2 days. And then I think when we come back, we have 2 full weeks and then a week of exams. So this is probably our last chapter. And thus last test will be at the end of this chapter for this quarter. Probably where we're going to hit. So, TBD, but that's most likely the case. So, I'm assuming that's where you were going to go with that question. All right, problems are 9, 13, 21, 25. And on 21 and 25, just do the thing with the limits like I did. You don't need to worry about drawing the picture. I mean, if you want to draw the little picture, you can, but I just skipped drawing the picture because pictures, that's not really mathematical. I would rather you do the math way of doing them. So, up to you, but do the limit way if you're going to do that. Intermediate value problems, let's do 47 and 49, and then 57 and 59 for the no real zeros greater than or less than thing.